Hey, hello, welcome AP Environmental Science students. Today we are working with some energy problems. We are going to get familiar with how to navigate through some free response questions regarding energy calculations. What's important is that you always show your work. So for the sake of this assignment, make sure you're recording your work on a separate sheet of paper. Go ahead and number your answers so I can see what work corresponds to each question. And that's a good habit to get into because especially when you get to an AP exam, showing your work and showing that you understand the calculations necessary to execute is going to be how you earn your points. So make sure you show your work, include units, set it up as neatly as possible, and as always, record your final answers in a neat, tiny box with units. So just be as clear as possible to communicate you know what you're doing, okay? So let's get started. Make sure you have a title, Energy Calculations, on your paper. And let's start with some background information. Please add some notes of things that you learned on this slide. You can title this section Notes. So know that just like in our PG&E bill exercise, we are dealing with units like kilowatt hours. So watts and hours are combined in these energy math problems. Know that kilowatt is a unit of measurement and hours, and when we are talking about using an appliance that's requiring electricity over a time period, we combine those units to represent kilowatt hours. So we talked about those in our PG&E bill. So example, if a TV which requires 20 watts of energy runs for 6 hours, we would communicate that this is requiring 1,200 watt hours, or what you will more commonly hear is 1.2 kilowatt hours. So how did we find this value? We took 200 watts and we multiplied it by 6 hours. So 200 times 6 will give you our number, and then watts times hours, that's how we find watt hours. And of course, we can convert this into kilowatt hours because kilowatts are 1,000 times bigger of a unit. So we're going to move the decimal 1, 2, 3 places over to convert 1,200 watt hours to 1.2 kilowatt hours. Okay. So also some other units that might come up are therms for natural gas, joules or British thermal units for total energy use. We will continue to talk about those units as they come up. What is important is that you have a good understanding of the metric system. So review those prefixes and understand how to navigate within the metric system. Again, that will benefit you if you were comfortable with this in chemistry. Maybe do some homework revisiting this idea, but in the metric system, we're just moving decimals, and it's important to know how these prefixes change the size of the unit you're using. So know that kilo with the little k is 1,000 times bigger. So a kilowatt is a unit that's 1,000 times bigger than a watt, for example. So to convert between the two, we move the decimal over 3 times. Okay, megawatts, we're moving the decimal 6 times over and 3 times between mega and kilo. So again, be familiar with the prefixes of the metric system. Let's dive into some problems and see how we're feeling about these calculations. So what I want you to do is go ahead and indicate that we're now starting problem number 1. And I'm not going to ask you guys to copy the question, but please write out what's given. So go ahead and write given, and then go ahead and list out what we're going to underline here. So the population of the United States is about 320 million people. So we can write that as a given. If annual consumption of petroleum in the United States is about 24 barrels per capita, which is per person, per capita is actually an important term to understand. And remember that it's referring to per person or per head. So if annual consumption of petroleum in the United States is about 24 barrels per capita, calculate the total, here's our goal, total annual consumption of petroleum. Put your answer in scientific notation. So what we're going to want to do is write out what's given and do some math to find our answer. So 320 million people. So that's 320 times 10 to the 6 people. And each of these people are using 24 barrels. So this is a number we're going to want to multiply it by 24 barrels. And that's per capita or per person. And I have people written there, so per people, per person, per people. When we do our math, your units should cancel out. So people and people go away, and our answer should be barrels, which is what we're looking for. So when we multiply this out, you can punch in on your calculator 320 times 24, and you should get, go ahead and do that right now, 7,680. And remember, we have some scientific notation, right? This is 320 million, so we want to include that million, 10 times the 6 there. And our units carry through barrels. Are we done? Well, it says put your answer in scientific notation. This is always a great practice to do. This is not as tidy as it can be. We need this first unit before our times 10 to the exponent to be a number between 1 and 10. So we got to move this decimal over to tidy this up. So imagine it's back here. We're going to move it over 1, 2, 3 places to the left. So we can rewrite this as 7.680 times 10 to the, and we got to change this now because we moved it over 3 places to make it smaller. So we got to make this exponent bigger to the 9th barrels. Okay, so go ahead and box that answer. For the sake of just focusing on calculations, we're going to write out our answers as specific as possible here. Chemistry people, I know you might be cringing with sig figs, but again, not all of us have practiced sig figs like lately, so we're going to leave our answer just like this. The focus of the AP Environmental test is not on significant figures. So if you guys don't know what I'm talking about, sig figs, don't worry about it right now. Okay, so let's keep going. Okay, draw a line on your paper. Let's make it clear that we are starting numero dos, number 2. In the United States, there are approximately, let's write down what's given. There are approximately 480 cars per 1,000 people. So we want to calculate the total number of cars in the United States. Put your answer in scientific notation. Okay? Whenever you're looking at a problem, it is in your best interest to set it up as a fraction. Dimensional analysis is a beautiful thing. If you know how to use it and navigate it, your life will be easier. So let's write this out. 480 cars, and this is per 1,000 people. So for every 1,000 people, there are 480 cars. How do we figure out how many cars there are in the United States based off of this? Well, we have to think back to our first problem. It was given, it gave us the population, right? We know the population of the United States was given as 320 million, and that was people. Okay, and I just like writing it over 1 because we're doing dimensional analysis and I like it that way. So that's our calculation. Pretty simple. Know that our units cancel out, people cancel out. So now we have cars, and all we have to do is some fun math. So we're going to do 480 times 320 divided by 1,000. And remember on the AP test, you will have access to a calculator. So I get 153.6, and remember we have our times 10 to the 6, and this is cars. We want it in scientific notation, but take a look, this number has to be worked with. So let's move our decimal over to tidy it up so that this is a number between 1 and 10. So move it in over twice. That makes this number smaller, which means we need to increase our exponent by 2. So we can write this answer as 1.536 times 10 to the 8th cars. Okay, a lot of cars in the United States. Cool, cool, good job. Let's move on to number 3. Go ahead and indicate in your notes. We are moving on to number 3. Let's write down a couple things that are given in this problem. So a tablet charger uses 15 watts and it takes 5 hours to fully charge. The cost of electricity is 15 cents per kilowatt hour. So all of these are good givens to write down. Let's separate out our work for each of these subproblems. So A, if this tablet is fully charged once a day, how many kilowatt hours does it use each year? Remember to convert watts to kilowatts. So let's start by figuring out electricity usage. We are going to take our 15 watts and our 5 hours to fully charge. So we need to do 15 watts times 5 hours, and that is 15 times 5 is going to be 75 watt hours, and that happens every single day. So this is per 1 day. Okay, so next what we're going to need to do is figure out how to convert this to years, right? So we need to think, what unit conversion factor could we multiply this by to get it to years? Well, we know days is going to have to be written up here. We are looking at per year. And we know that there are 365 days per year. I guess we could ignore the leap year thing right now. If you wanted to, you could do 365.25, but if you're showing your work like this, I don't think you'd be marked down for that part of your calculation. So let's look at our units. Days cancel out. Our final answer for part A will be watt hours per year, and then we might need to do some conversions to convert it to kilowatts. So let's go ahead and calculate this out. We're going to do 75 watt hours times 365, and that is per year. So go ahead and do that math right now. So I got 27,375 watt hours per year. And it wants our answers in kilowatts. So again, we're going to imagine the decimals back here. Move it over. We know kilo is 1,000 times bigger of a unit, so we want to move this over 1, 2, 3 places. So it's going to go there. So we're going to say our final answer is 27.375 kilowatt hours per year. Okay? Great job. So now let's use this additional information about how we're going to pay this bill and how charging this specific tablet based off of the cost of a kilowatt hour is going to be, part of our PG&E bill. So all we need to do is take our answer from A. We know that we are using in a given year, right? Annual cost, 27.375 kilowatt hours per 1 year. And it's going to cost us 15 cents per kilowatt hour. Let's take a look at our units. Kilowatt hours cancel out, so we should be left with dollars per year, which is our annual cost. That's exactly what we want. So go ahead and do this calculation to figure out how much of our PG&E bill over the course of a year we're paying just to charge this tablet every day. Okay, when you multiply this out, you should get $4, and we're going to round it up to the nearest cent, because on a bill nobody rounds your bill down. So on my calculator I'm looking at 4.10625, so I'm going to round it to $4.11, and of course that is the annual cost per year. Okay, awesome job, guys. Let's take a look at one more problem. Great job. Number 4. Let's indicate in our notes we're working on number 4. And let's write down some given information. So a home uses 10 100-watt light bulbs. So it's 10 light bulbs. Drawing light bulbs is fun. There you go. So it's 10 light bulbs that are using 100 watts, 5 hours per day. How many kilowatt hours of electricity are consumed in 1 year by using this set of light bulbs? So let's think about how we're going to set this up. This one's a pretty simple calculation using all this information. So we have 10 bulbs, and each of those are using 100 watts over 5 hours. So let's do this calculation, and that's per day, 5 hours per 1 day. So if we do this math, go ahead and multiply this out to figure out how many watt hours we're using per day. 10 times 100 times 5 should give you 5,000 watt hours per day. We want to figure out how many kilowatts of electricity we're using, not in just 1 day, but over the course of a year. So 5,000 watt hours per 1 day. We need to convert this into kilowatts. So let's think, how many kilowatts are in a watt? Well, we know a kilowatt is a bigger unit, so 1 kilowatt is equivalent to 1,000 watts. And that calculation is going to allow us to convert watts to kilowatts. And of course, this is an annual calculation, so we want to convert days to years. So we're going to use our 365 days per 1 year to do this calculation. Let's take a look at our units and see how we're doing. Watts cancels out. We have days cancel out. So our answer should be in units of kilowatt hours per year. We're looking good. So go ahead and do that math. We're going to multiply all the numbers that are on the numerators, divide everything that's on the denominator. And we should be looking at a number. I'm going to write it down here, running out of room. 1,825. And let's take a look at our units. we have hours times kilowatts. We write that as kilowatt hours, and that's per year. So that's our annual, that is our annual use of electricity or consumption of those 10 light bulbs, 5 hours per day. Cool. Good job, guys. Give yourself a pat on your back. Please make sure you're showing your work, you're boxing your answers, and you're having fun. Okay? Good job. Let me know if you guys need help. Let me know if this was helpful, or if you'd like more review problems like this. I'm happy to give you more support. Have a great day. Talk to you soon. Bye.